Hi guys, this is Mrs. Rooker. I'm going to be deriving the unit circle with you guys, which basically just means coming up with the unit circle. Um, the unit circle is something that is going to become your best friend in trig next year. If you don't understand it and you don't learn it well, you don't essentially memorize the important parts of it, then it will be like a worst nightmare. So we're teaching it to you now. This is something to make sure you understand now. And if you don't understand it, study it over the summer or get some extra help so that you can do well in trig next year if you are moving on to trig. So basically what the unit circle is a circle where the radius is 1. So that's why we call it the unit circle, because the radius is going to be 1 unit. And now we're going to kind of work backward and figure out a bunch of important stuff about the unit circle, or all the important pieces of it. So we are going to review right triangles. So the first one we have here is a 45, 45, 90, but the radius, which is going to end up being the hypotenuse here, is 1, because we're going to be doing this for the unit circle. And remember, to get from the hypotenuse of a right triangle, or 45, 45, 90 right triangle, to a leg, you divide by root 2. So we're going to do 1 divided by root 2 to get to the side. But we can't leave it like this. We need to rationalize the denominator, so we have to multiply top and bottom by root 2. So we'll end up with root 2 over 2. And that's what this side will be. And remember, the sides are equivalent on a 45, 45, 90, so this one will also be root 2 over 2. All right, so that's the sides on a 45, 45, 90. On a 30, 60, 90, if the hypotenuse is 1, to get to the shortest side, we just cut it in half. So this will be 1/2. And then to get from the short side to the medium side, you multiply by root 3. So this one would have to be root 3 over 2. All right, same idea on this one. It's also a 30, 60, 90, just positioned differently. So to get from the long side to the short side, we divide by 2. So y will be 1/2. And to get from short side to medium side, we multiply by root 3. So this will be root 3 over 2. And we're going to use all of that kind of important information to come up with all the measurements for the first quadrant. So given the following diagrams that are in the first quadrant, label the corresponding point, put in the first blank, and the radian measure, we're going to put it in the second blank. Remember, your radius for the unit circle is always 1. So this right here is the radius of the unit circle, and it's going to be 1. And what we need to figure out here is what this length is and what this length is. And the reason we're doing that is because this, what we're trying to find here, we're trying to find the point, this coordinate point on the unit circle. And that coordinate point is going to be an x, y coordinate. So we need to find what x is and what y is. If this is 1, because the radius on a unit circle is always 1, and we have a 30-degree angle here, we're going to go from the long side, which is 1, to the short side first. To get from long side to short side on a 30, 60, 90, we divide by 2. So the y is going to be 1/2. And to get from short side to medium side, we multiply by root 3. So x is going to be root 3 over 2. And now we just write that as a coordinate point. Remember, coordinate points always go x first. So root 3 over 2, comma, y second, so 1/2. And that's the coordinate point at our 30-degree angle here. The next blank, we are supposed to put the radian measure. Now 30 degrees is the same as pi over 6. And that's one of the angles that you're going to want to memorize. Eventually, you'll memorize this coordinate point as well, but that's not something we expect you to memorize right away. It's going to be kind of a building process. All right, the next one, we need to find this coordinate point here. This is the length for the x. This is the length for the y, and I should have done a little right angle there. These are supposed to be right triangles. Here we have a 45, 45, 90 triangle. The radius on the unit circle is always 1. And the sides, we did this up here, the sides are going to be root 2 over 2 on both of these. So the x coordinate is root 2 over 2, and the y coordinate is also root 2 over 2. And then the next thing we need to do is write the angle in radians. 45 degrees is always pi over 4. All right, and then the last one in quadrant 1, we need to find this coordinate point. This is a 60-degree angle, which means we've got a 30, 60, 90-degree triangle. To get from long side to short side, we divide by 2, so 1/2. And to get from short to medium, we multiply by root 3. So this would be root 3 over 2. The x coordinate is right here, so 1/2. And the y coordinate is root 3 over 2. So you'll start to kind of notice some patterns here. The 30-degree angle and the 60-degree angle have the same numbers. The coordinates are just switched. And then also we need to write this in radians. 60 degrees in radians is pi over 6. Again, these, whoops, not pi over 6, sorry guys, pi over 3. I always kind of remember those to be opposite, like you would expect pi over 3 to be with the 30, but it's not. Pi over 3 goes with the 60, and pi over 6 goes with the 30. It's kind of backward. But then pi over 4 goes with the 40, which I feel like kind of makes sense. That's an easy one to remember. But what we just did was we came up with all the coordinate points, all the important coordinate points in the first quadrant. We are going to do the same thing in the second quadrant. Doing this, we don't really care about the 120-degree angle. What we care about much more is the reference angle, which, remember, the reference angle is the angle drawn to the closest x-axis. So this whole thing would be, would be the x-axis there. So the little red tick mark that I drew, that's the angle we care about. Halfway around, or a straight line would be 180 degrees, so this must be a 60-degree reference angle. And if that's a 60-degree reference angle, then we again have another 30, 60, 90 triangle. And again, the radius is always 1. So to get from long side to short side, we divide by 2, so this will be 1/2. And to get from short side to medium side, we multiply by root 3. So this is root 3 over 2. And then we write this as a coordinate point. Remember, x coordinate goes first, so 1/2 first, but we have to be careful. Because this is going to the left of the origin, it's negative. All of our x coordinates in the second quadrant are going to be negative because they're going to the left. But then we're still going up root 3 over 2. So our y coordinate is root 3 over 2. And then 120 degrees might not be one that you have memorized, but what matters is we know our reference angle is 60 degrees. If our reference angle is 60 degrees, then we know that this is going to be a pi over 3. Because if the reference angle is 60, it's going to be some multiple of pi over 3. Sorry, got cut off. So this should be some multiple of pi over 3. Anything that has a reference angle of 60 will be a pi over 3. It might just have a different number up top here. If it's in quadrant 1, it's just pi over 3. If it's in quadrant 2, it's going to be 2 pi over 3. We'll talk more about all of those in a little bit. right, next one. We gotta hurry on this. I'm gonna start trying to go a little faster. 135 is the angle. To find the reference angle, we do 180 minus 135, and we get that this is a 45-degree reference angle. Meaning, this is quick and easy. This should be root 2 over 2 and root 2 over 2 anytime we have 45-degree angles. But since this is going to the left, it's going to be negative. So my coordinate point is going to be negative root 2 over 2, comma, positive root 2 over 2. The y values in that second quadrant will still be positive because it's still going upward. All right, finding the radian measure. Because this is a 45-degree reference angle, we know it's going to be an over 4, a pi over 4. Because anytime we have a 45-degree reference angle, it's going to be over 4. But because it's in the second quadrant, not the first, it's not going to be just pi over 4. And we don't want to do 2 pi over 4, because 2 pi over 4 would reduce to pi over 2, which is not the same as a pi over 4. So it's not going to be 2 pi over 4, it's going to be 3 pi over 4. All right, moving on. 150, if we subtract that from 180, we get that the reference angle is going to be 30 degrees. The short side is going to be 1/2. The medium side is going to be root 3 over 2. And it's negative since it's going to the left. So the x-coordinate is negative root 3 over 2. The y-coordinate is 1/2. And to get the reference angle, to get the degrees in radians, since it's a 30-degree, the angle measure in radians. Since it's a 30-degree reference angle, this is going to be a pi over 6 multiple. But it's not in the first quadrant, it's the second quadrant. So it's not just going to be pi over 6. We don't put 2 pi over 6 because that would reduce. We don't put 3 pi over 6 because that would reduce. We don't put 4 pi over 6 because that could reduce as well. So the next best option is 5 pi over 6 is what we're going to have in that second quadrant. All right, quadrant 3, I'm just going to pause the video and do this one really quick and then talk about why we came up with the ones that we did. So I did the first two and I'll kind of walk through them. This is a 30-degree reference angle because 110 is 30 degrees past 180. So the 30-degree reference angle means to get to the short side, we divide this by 2. So the short side is going to be 1/2. The long side, or the medium side, is going to be root 3 over 2. I made them both negative because the x-coordinate is going to be negative because we're going to the left of the origin, which is right here. And the y-coordinate is going to be negative because we're going down. So anytime we're in quadrant 3, x and y will both be negative. And that's a really important thing to remember, is where our signs are positive versus negative. All right, and then since the reference angle was 30, I knew it was going to be a pi over 6. So I knew it was pi over 6. And it was 5 pi over 6 when we had a reference angle of 30 in quadrant 2. So we're going to count past that. Past 5 is 6 pi over 6, which can reduce. So it's not going to be 6 pi over 6. And then the next one is 7 pi over 6. So it's going to be 7 pi over 6 in quadrant 3. All right, the next one, it's a 45-degree reference angle because it's 45 degrees past 180. Those are easy, root 2 over 2 for both sides, x and y. Both negative since we're in the third quadrant. And then I knew it was going to be a pi over 4 because anytime we have a 45-degree reference angle, it's pi over 4. And in quadrant 2, our pi over 4 was 3 pi over 4. And we need to go past that. So 4 pi over 4 is no good because that reduces. Go one past that, 5 pi over 4 doesn't reduce, so that's our guy. All right, last one in this quadrant. 240 is 60 degrees past 180. So our reference angle is 60. Our radius is always 1. To get from long side to short side, we divide by 2, but this is going to be negative because we're going to the left. And then to get from short side to medium side, multiply by root 3. again, going to be negative because we're going down. Our x coordinate is -1/2. Our y coordinate is -√3/2. And then to find this in radians, the reference angle is 60 degrees. So this is going to be a pi/3. Why did I write 6? Sorry. This is going to be a pi/3. Because anytime we have 60 degrees, it's pi/3. But since it's in the third quadrant, it's not going to be just pi/3. There's going to be a number there. Our last one for pi/3 was 2 pi/3. So we count past that, it would be 3 pi/3, which reduces. We don't like that. And then the next one after that would be 4 pi/3. That doesn't reduce, so that's our guy. Go ahead and copy all this stuff down if you don't have it down already. And then the last quadrant, if you want to try this on your own, pause the video. It's really good to kind of be able to figure this stuff out on your own. If not, you can just watch me. We need to find the reference angle. This is going to be a 60-degree reference angle because it's 60 away from 360, which would be all the way around a circle. All right. If the radius is always 1, divide by 2 to get to the short side, multiply by √3 to get to the longer side. That one's going to be negative because we're going down, but the x is going to be positive. So this is going to be 1/2, comma, -3/2. Sorry, √3/2. And then to find the reference angle, or the reference angle is 60. To find that in radians, we need to put it pi/3 because 60 degrees is always pi/3. But then because it's in the third quadrant, it's going to be 5 pi/3. And we'll talk more about that in a minute, but the last one we had was 4 pi/3, so we just count one past that and we get 5 pi/3. All right, next one, 45. Making this √2/2. This would be -√2/2. So our coordinate is √2/2, comma, -√2/2. And this will be a pi/4 because 45 reference angle always is. And it's going to end up being 7 pi/4. In our previous quadrant, it was 5 pi/4. So you go up to 6 pi/4, but that reduces. So the next best one is 7 pi/4. And then the last one, 30 degrees, making this 1/2, or negative since it's going down, and this √3/2. So the coordinate is √3/2, comma, -1/2. And then, since the reference angle is 30, this is going to be a pi/6. Our last pi/6 was 7 pi/6. So the next one would be 8 pi/6, but that reduces. 9 pi/6 also reduces. 10 pi/6 reduces. 11 pi/6 is the first one that doesn't reduce. So that is our guy. All right, so now we are going to combine all of this into the unit circle. And I'm actually not going to use all of that stuff we just found. I am going to use a little trick that I like, and a lot of the trig teachers like to use to figure out all of the angles and all the coordinate. What's the word I'm looking for? All of the coordinate points on the unit circle. So first thing is first we'll do all the angles. We always start on the positive x-axis. That's going to be 0 degrees. And yeah, why don't we just go all the way around with degrees first? This first tick mark is always going to be 30, then 45, then 60. Those are our important angles. Straight up and down is going to be 90 degrees. And then from here we'll add another 30. These larger gaps are always increments of 30. The smaller gaps are increments of 15. So this is going to be 90 plus 30 is 120. plus 15 gives us 135, plus 15 gives us 150, plus 30, bigger gap here, gives us 180. Keep going around. Plus 30 is 210, plus 15 is 225, plus another 15 is 240, plus another 30 is 270 degrees. All right, plus another 30 is 300 degrees, plus 15 is 315, plus another 15 is 330, big gap here, plus another 30 brings us to 360, which hopefully makes sense because that's all the way around the circle. Now we'll do all the radian measures. 0 degrees is also 0 radians. And you're going to have to start memorizing these things. 30 degrees is pi over 6. So 30 always goes with pi over 6. 45 degrees is pi over 4, always. 60 degrees is pi over 3. And 90 degrees is pi over 2. All right. Now, this side, this is going to be important to know. This side will just be mirrored or reflected over into quadrant 2. So quadrant 1 and quadrant 2 look really similar, just a mirror image of each other. So since this one over here was pi over 6, it's going to be a pi over 6 over here. Except it can't be just pi over 6 because it's in quadrant 2. So we have to count up from there. We don't want 2 pi over 6, we don't want 3 pi over 6 because those both reduce. 4 pi over 6 also reduces. So 5 pi over 6 is the next best one. Another important thing, and actually what's pretty helpful in determining what's in this quadrant, is knowing that 180 is always the same as pi, and all the way around the unit circle is going to be 2 pi. So those are important to kind of help determine where certain radian measures go. So another way, instead of having to count up to 5 for this angle, is we could have thought of the fact that this is pi, which if we were to get common denominators with pi over 6, that would be the same as 6 pi over 6. And this has to be less than that since it's not quite that far around the circle. So this is 6 pi over 6. Or sorry, 5 pi over 6. It's kind of a lot of different ways to think about this, so hopefully that's not too confusing. All right, the pi over 4 is going to be reflected over here. But it can't be just pi over 4. It's not going to be 2 pi over 4 because that reduces. So it's got to be 3 pi over 4. And then the pi over 3 reflects over here, but it's not going to be just pi over 3 because it's not in quadrant 1. So I just add 1 to that. It's going to be 2 pi over 3, and that doesn't reduce, so we're good. All right, then same idea. This second quadrant is going to reflect over itself into the third quadrant. So 5 pi over 6 reflects over here. So this one will be a pi over 6, but it's not going to be 5 pi over 6. Count up from there. It's not going to be 6 pi over 6 because that reduces. So it's got to be 7 pi over 6. And then the 3 pi over 4 reflects here. So this will be a pi over 4. But I'm going to count up from 3. Count up from 3, I get 4 pi over 4, which would reduce, so it's not that. So it's going to be 5 pi over 4. And then the pi over 3 is going to reflect down here, so this will be a pi over 3. It's not going to be 2 pi over 3. Count up from there, we get 3 pi over 3, but that reduces, so it's got to be 4 pi over 3. And then to get our last quadrant of our unit circle, we're going to reflect everything in quadrant 3 over to quadrant 4. Or you could reflect everything from quadrant 1 down into quadrant 4. But I'll just do 3 over to 4. So the pi over 6 reflects over here. This will be a pi over 6. Count up from 7. 8 pi over 6 reduces, 9 pi over 6 reduces, 10 pi over 6 reduces. So it's got to be 11 pi over 6. Which is really close to 6 pi over 6, which would reduce to 2 pi. So it should hopefully make sense that those are close together. All right, and now we'll reflect the pi over 4 over here. So this will be a pi over 4. And we're going to count up from the 5 pi over 4. 6 pi over 4 reduces, so it's going to be 7 pi over 4. And then the last one in this quadrant, we're going to reflect the pi over 3 over here. Count up from 4 to 5 pi over 3. Doesn't reduce, so we're good. And then this one down here, just like this one up here, it's going to be reflected over. Pi over 2 reflects down, so this will be pi over 2. But we have to count up from pi over 2. So up from pi over 2 would be 2 pi over 2, which reduces, so it's not that. Count up from there, we get 3 pi over 2. So this one will be 3 pi over 2. That is all of our angles and all of our radian measures. So you can use those kind of little tricks to figure out where every angle goes. Eventually you might start to memorize them, but the whole reflection idea hopefully is helpful. So really what you need to do is memorize the first quadrant where everything goes there, and then you can reflect it to find the stuff in the other quadrants. Right, now we need to find the coordinate points. The coordinate point here is always 0, 0. And then I have a little trick for you. Your coordinate points will always be, all of these coordinate points will be fractions with denominators of 2. And this is just something you'll have to memorize. It's always going to be over 2. You start with the y coordinates and you start counting up from 1. So this will be 1, this will be 2, this will be 3. The 2 and the 3 need roots on them. All right, and then it's just backward for the x coordinates. So x coordinate, you're going to start with 3, then 2, then 1. And that's how it's going to work for every quadrant. You start with the y's, count up. For the x's, you count down. This coordinate here up top is easy to find because remember our radius is supposed to be 1. So this height here is supposed to be 1. If you think about, this is the origin, and xy coordinates, this is supposed to be an xy coordinate, we moved 0 to the left and right, but we moved up 1. So that's the point 0, 1 up there. If we want to find this quadrant, or this coordinate next, it would be, this is going to be a -1 length, because the radius of the unit circle is always 1. This would be the coordinate point -1, 0, because we didn't go up at all. Alright, and then to find these, in quadrant 2, our x coordinates are always going to be negative, because we're moving to the left. But our y coordinates will still be positive. And you can just reflect these coordinate points from quadrant 1 into quadrant 2. So this will just be √3 over 2, comma 1/2. And this will be √2 over 2, √2 over 2. And this will be 1/2, comma √3 over 2. But all of the x coordinates are negative. And then this quadrant is just a reflection of all of these points, but both the x coordinates and the y coordinates will be negative, because in quadrant 3 we're going left and down, so everything's negative. So this will be -√3 over 2, comma -1/2. This will be -√2 over 2, comma -√2 over 2. And then the last one will be -1/2, comma -√2 over 2. All negatives for both quadrants, or for both coordinates there. To find this point straight down, the x coordinate is going to be 0, because we went left to right, 0. And it'll be -1, because we had to go down to get to the y coordinate. Alright, and then just reflect all of these green points into quadrant 4. But in quadrant 4, the x will be positive and the y will be negative, because we're going down, but we are going to the right. So this will be, oops, that was supposed to be √3 over 2 on that, on the the y coordinate there. All right, so we'll have negative, or we'll have 1/2, comma, negative root 3 over 2. Because we're reflecting this point over here. Now reflect the middle point, root 2 over 2, comma, negative root 2 over 2. And then the last point is going to be root 3 over 2, comma, negative 1/2. So this is very much something that we need to practice and talk about more in class. Wow, they also want us to write in decimal values for radians as well. So I'm going to pause the video and do that for you guys so that I don't waste any more time. But this is definitely something to talk about with your teacher in class and practice a lot. I'm actually going to write in the decimals for all of the radians because that's a lot of them. But I'll do them just for each of the north, south, east, west points. So pi over 2, the top one up there, I'm just going to type that into my calculator. Pi divided by 2 is about 1.57. Pi is 3.14. And then 3 pi over 2 is about 4.7. And 2 pi is about 6.28. And those are kind of good things to know for future problems, but it's not something that you're going to need to know every day. All right, thank you guys. Have a good one.